So my name is Kennedy Karoko. I'll be talking about intra-service communications in Go using gRPC. And I think before we get started, I would like to ask if anybody can maybe tell us what gRPC is. I think we all know what microservices are, since we'll be talking about service-to-service communication. Let's get started. So we all know about microservices. They are nice. They enable us to decouple our system so that we can be able maybe to test each feature individually. We can be able to scale each feature individually. Also, it allows teams to be able to work on a specific feature, without depending on another feature. So you can have two different teams, and each team is working for a specific feature. Also, fault isolation. So if you notice, like, let's say one feature is prone to errors, you can be able to isolate it and be able to deal with that. So microservices are nice, and maybe this is just an example of an API gateway pattern. So we have services there, and each one of them has its own DB, plus an API gateway. So if you want maybe to focus like on mobile or web, it's just an example. I'm sure we all know about that. So, but there are some red flags. I know you guys like red flags a lot. I don't. But the first thing is latency. So the fact that you have to communicate from one service to another, like each and every request has to do like a round trip. So you need to go to a service over a network and come back with a request. Also, if maybe one service is deployed in a different part of the world and another one, then you can see there is an issue there. The latency is quite high. Also, when you're dealing with REST, you're of course dealing with JSON. That is text. Sometimes it can be too large. I'm sure you can be able to compress that. But we're going to be able to talk about that and how you can be able to minimize that using gRPC. Also, reliability. These are the issues that you can be able to deal with. I'm just highlighting some of the issues so that, like, if you compare REST and gRPC, when you're like, you are communicating from one service to another, we can be able to see how either is efficient in doing something. So reliability, what if one service goes down? How do you deal with it? You can be able to deal with it, but I think it's all a matter of convenience and how we are able to deal with those issues. Also, performance. I think for when you're dealing with REST, it's all about serialization and deserialization. So you have to encode and decode JSON, which is text, and it's not closer to the machine. And we're going to see why. I just don't want to maybe say it at this point. So now that we have seen the red flags, let's introduce gRPC. So in REST, you're used to using JSON, but for gRPC, you use protocol buffers. So it's so protocol buffers, unlike JSON, you're just dealing with text. Let me just go and just show you how that looks like. So you can already see it's strongly typed. So unlike in JSON, or you can be able, maybe you pass something like string, and maybe your intention was to pass a number, and you can already see how efficient this is. So if I want the ID to be an integer, I can just define it. If I want any other thing apart from a string, I can be able to use that. And another thing about RPC is that it uses binary for encoding. So that means that you're closer to the machine already. You don't need, the machine already understands the communication between one service to another, and like having to understand requests and responses via text, which is JSON. So that is the introduction of gRPC. It's a remote procedure call framework developed by Google. It's built on top of HTTP2. I'm sure REST heavily relies on HTTP1. We already know HTTP has its advantages over HTTP1, one being multiplexing. So you can be able to send streams of data or receive streams of data, which is quite efficient. And we're going to see an example of that. So those are some of the companies that use gRPC. We've already talked about protocol buffers, and this is just an example. So talking about protocol buffers, what happens first, you define more of like a model. So I'm sure like even when you're coming up with APIs, you want to know like how is my user going to look like? How is whatever object that you're dealing with, how is it going to look like? So you start by defining that, and then we have also services. So services, it's like you're setting a contract that this is what I want my system to do. I want to create something, I want to read something. So in short, you can have your CRUD here, something like that. And in this service, you can be able to send a stream of data or receive a stream of data. And I'm going to show you an example of that soon. One thing we know, like Go doesn't like support enums out of the box. You can implement that using things like IOTA, but if you're using something like protocol buffers, you can be able to access that immediately. So how does gRPC solve communication problems? Already we can see the lower latency aspect because it uses HTTP2, and just to mention, it supports also SSL out of the box. So even when you're like testing locally, you need to say that the connection is insecure. So you have to explicitly say that, hey, I want an insecure connection because it's already secure enough. Also, efficiency realization, unlike in REST, you're dealing with protocol buffers which have a binary format for encoding. Also, when it comes to service discovery and load balancing, it's much easier to integrate that, and we're going to see that. Also, the security aspect that I've just mentioned right now. So let's see a comparison. So my goal here is just to make sure that you ditch REST for the rest of your lives and adopt gRPC from now on. So you can see data format, just like a summary of what we've talked about. The latency of REST is higher. The communication style is typically synchronous. By that, it's like one request, one response. But then gRPC supports streaming. Also code generation. So once you define that protobuf, the next thing you do is to generate code. And then I'll use that code within your service. Performance, already talked about that. Let's see examples of gRPC API. So we have 4, we have unary, we have server streaming, client streaming, and bidirectional streaming. And I think from the naming, you can already tell how that works already. So unary, it's just like the traditional REST way. You send one request and you receive one response back. You can see that. And then for server streaming, you send one request, and then the server sends you like a stream of data. So a use case is like getting the latest currency exchange rates. So because it's data that you're getting that's constantly changing. Same to client streaming. So it's like you send a stream of data and receive just one response. So if you're like uploading something, especially like in bytes format, this is quite fast and yeah, convenient as well. So bidirectional streaming, it's more of, I can say, like WebSockets, but even better. So it's like you can send a stream of data and receive a stream of data as well. So these are examples of how you define those APIs. I showed you like as the service part of the protobufs. And you can see this is the unary one where you're just sending one request and receiving one response back. For server streaming, you send and you receive a stream. So you just only have to add like a stream before the request or the response. This is a message. I showed you how a message looks like. I think we're going to see that again. And bidirectional streaming is that. So you just add a stream. That's what defines where the stream is coming from. How does gRPC work? So when you're dealing with microservices, of course, one service is giving out data and maybe another service wants to read data. So the one that's producing the data is is the server, and the other one will act as a client. So that's how it works. So you write your protobufs, you generate the code, and then the client can basically be able to access that. So how do you create a gRPC API? First of all, you need to install a compiler. One thing with gRPC and these compilers is that it supports so many languages, from Go, from Java, C++, anything. So you can even have one service that supports one language and the other that supports another one. So you start by defining your protobuf. That's how it looks like. For example, here I have like a small book service that's just getting a book. The message is that, and the request is that. So you can see I'm passing the requests that I am sending, and then I return just a book object, which I define as a message there. If you're asking how do you deal with something like arrays, you just add the repeated keyword there, and then the data type, and then the name. So that means that I'm sending an array of strings. That's how I'm defining it. Next thing, you generate server and client stubs. Yeah, that generation part might look scary, but I also don't know exactly how to put it. I just know it works that way. So I just go to the documentation and do something like that. All I know is that the generated code will be somewhere in a proto folder. The rest I don't know, really. But it works. Yeah. The next thing, you set up the server, and you start this an instance of the handler part. So in the generated server stubs, I'm going to show you there is this struct here, and I'm sure, I think someone talked about interfaces, and when you embed that struct here, it means it's like you're inheriting all its properties there. So that means that the handler now implements the server aspect of gRPC. And all you need to do is listen to a port, and then you register. So this is in the generated server stubs. And then you just listen. So this is the example. So this struct here has a method that exactly looks like this. So from the get book part to this makes sure that our handler implements that exact method. And then that's the server part. If you want to set up a client to read from that server, then you just dial using gRPC. And as you can see there, I'm setting insecure.new credentials to just say that, hey, I'm testing locally. I don't have any SSL, just allow me to do that. And after that, you can see I'm now getting the book service. So that is from the stubs that have been generated. We're going to see that more just shortly. And then I'm just calling some function. This is just an example. Of course, it's not practical to have something like this in production. And you can see how I'm doing something. I'm just accessing the client, and I'm invoking a function. So unlike in REST where you have to access an endpoint, you just invoke a function, and you're good to go. So I'm just going to, first of all, before we see a microservice example, I'm just going to show you an API and how you can be able to test that real quick. Let's see here. So this is just like an API, and the first thing here, you can see I have some protos here. I just have like a folder where I define the protos, and I have just a name there and the version, so that if I maybe want another version, I can define that as well. This is my Rocket proto. You can see I have a message. I have the endpoints. These are like a contract that I'm saying, hey, this API is going to implement these CRUD. So I have like create, add, and delete. I have a request there. I have a response. So this is just the messages that I'm passing here. I hope that's clear. And then after that, now when you run the So when you run this thing here, that I don't know, so what happens is it generates this code here. So you can see, I just pointed to that directory and it generates here. So if you just want to use protobufs directly, you can access them from here, but for gRPC, there is a file as well there. So this is auto-generated. Of course, I can't edit. If I want to change something here, I have to come and edit something here and run the code generation for it to generate that code. So this is from a server aspect, so it's just an API. So there is no client here. But for me to have that server aspect of things, in my handler here, I have like transport gRPC. You can see my struct here. Of course, this is just for me to be able to pass the service if I want to test it and make sure that the handler doesn't depend directly on it. So I have this, and if you come here to the gRPC part, where is it? You can see it right here. It's just a struct that has these methods. And I'm just getting these exact, the way it looks like, and I'm coming to my handler and adding that to my handler. So my handler now implements the server. And just like that, you're now connected to the server. So now you can now continue to maybe to the business logic and to the storage layer. And when it comes to now serving, so this is just a server, just the way I showed you how you connect to a server, you listen, and you get a new server. So I'm using the gRPC Golang package to get that, and then I serve it. So this is also inside those files. And just like that, I have my server and ready to go. So Postman supports that. I'm just maybe going to try and run something here. Just to show you, this is just an API. There's no microservice here. So I have some rockets. And then maybe I can edit something here. I don't know if it will be valid. Okay, it's not valid. So I'll just get it because it already exists in the DB. I'll have to start generating like a valid UID. So Postman, when you come here and try to create a new request, it's somewhere, maybe here. You can see this gRPC part. So all you do is come and do that. Okay, let me just show you real quick before time is over here. So you select the protobuf. So you go to your directory and select the protofile that you want those endpoints for. Once you select that, they will be listed there and you can be able to access it. And just here you type maybe localhost, something like the port that you've exposed. So I'm just going to show you here so you can see I can be able, if I want to add a rocket, and these are the services, the services that we defined, you can be able to select it from there. So if I just invoke it, we have our rocket and ready to go to the moon. Great. So that's just the API part. Let's see the microservice part example. So this is the structure of it. So as you can see, I'm only using gRPC for service-to-service communication. So I have the gateway that is exposed to the outer world. So this is, if someone wants to access this system, this is just an example. They'll come to the gateway service, and then the gateway service forwards an order to the order service. You can see I'm using RabbitMQ because gRPC, I'm using it for synchronous communication. I'm one person who believes that it's not enough to just, if you're building like a large technical, you're solving a large technical problem. I don't think that synchronous communication is just enough for everything. I feel like you still need some asynchronous communication. And as you can see between the orders and the payments, I have an event that I'm publishing, and then when the payment is made, then I'm fanning it out to the catalog to deduct the quantity and the orders to say, hey, your order was successful. So let's see. We have 4 services: the gateway, orders, catalog, and payments. I made like something like a bookstore, and let's see. It's called Book Mesh. Again, I'll have to do something here so that you can see. That's too large. So you can see I have the services here. Each service has its own structure, and this gateway is the entry point. But what I've done is that I've created like a directory, and I'm using it as a library so that I can be able to access it from any service. As you know, the way you import stuff in Go, maybe you have your repository in GitHub, and you can be able to use that to access that shared package. So this is where I have my proto, and this is how my proto looks like. I have my order service and the book with quantity. I'll just show you how it works, because if I go into details of my thought process, time will just it will not be possible to finish that. And then I have my catalog service. So this is, if I get an order, the order service needs to communicate to the catalog service to see if the stock is quite enough. So I check, hey, do I have a book in the catalog? Or even just like get books from there. And that's it. So you can mostly see, because the payment service doesn't rely on gRPC, just relying on RabbitMQ for that. So let's say, so what I've done is, I mentioned about service discovery. I'm using service discovery to be able to know the services that do exist. Again, I have a package here. I'll share this repository for you to be able to go through it. I'm using console to be able to discover the services. And let's say for the gateway, I'm just coming here. Let's see. So I'm registering that. Let me just reduce it. So you can see I'm registering this. So one issue with microservices is that you have to write too much boilerplate code. Like you have to write these for the gateway, you need to write that for the catalog and like in more. So I think that's a trade-off that you need to take. So once I register that, of course, when I want now to talk to the orders service, I have a gateway in here, and this gateway implements the orders client stub. So this is how now I'm able to communicate, and I'm using gRPC now to discover and now be able to create that order. So same thing, this is the gateway. So for the orders as well, actually for the orders, it's the same thing. You see I have a catalog gateway that implements the catalog stubs. I'm sure you saw something like this. I didn't use the get books. I saw no need for it. So it's just right there existing. And if I want to use that, if I go to transport handler, so just before I get there, you can see in the catalog, because maybe it's acting as a server to the order service, I am implementing this just the way I showed you, and now I'm able to implement that. So this means that this catalog service implements the catalog server. Yeah, so it's basically that. So if something is a server, you need to implement this in the handler. If it's the client, I'm using the gateway to be able to discover that service and send requests to that. Would you like to see it run? I hope it works. It was working. It was working. So if it fails, I'm not to blame for that. Let me just spin these up real quick. So you can see I have my services here. I don't know if it's possible to enlarge these. I have my gateway, I have my orders, I have the payments. I'm using Stripe for payments, and then catalog. So it's in test. So if I come here and, which one was it? Yeah. So the gateway is running. Let's see the payments. And just here, I need to enable the webhook for Stripe. And the catalog, I can't really see. We have that as well. So I'm just going to use Postman here to create an order. So remember that from the outside world to our system, we're just using REST to be able to access the gateway service, and then from there now we're using gRPC for that. So if I come here and create an order, so the gateway service has now communicated to the order service, and now the order service is now expecting us to make a payment, so that the payment service just finds out an event that, hey, I've been able to do that. And by the order service at this point has also communicated to the catalog service, just to make sure that this book, for example, you can see this is the same book, the quantity in the catalog is the same. So I'm using in memory to store that. So like I have an outside database for that, but this is just like to show you how it works. So I'm just going to try and initiate some Stripe. And before I click on it, I'm using Mongo just to store the orders here. Let me go to these orders, view. I think it's this one. And you can see there's already like a Stripe payment, because I'm storing those books in the catalog with the payment link. So it has already given us a payment link that we are going to use, and it's the same one as this one here. So if the payment is successful, and maybe we can come here and see it's successful over here from the webhook, then our MongoDB there should be no payment link, because the payment is successful and the order should act as paid. So if I come here, fingers crossed, it should work. So we have no payment link and the status is paid. So that's how we communicate between one service to another in a nutshell. So I'll maybe share this repository later on so that you can go and refer by yourself.